Hello students, welcome back to the series of lectures of Mathematics 1B of Intermediate. Now here we are discussing the exercise 9A of the differentiation chapter. Well, we were discussing this chapters in so many previous video lessons. Those who have not watched those of them, please go to the channel playlist and get them notified here. And the immediate previous video lesson of the exercise 9A, the first part in that there are 15 problems. For that you can click on the iCard and you will be notified. Now we will continue the second part. I have noted down the second part here. If f of x is equal to 1 plus x square plus so on plus x to the power of 100, then find f dash of 1. Here asked f dash of 1, differentiation of 1. The function f of x is given. First we will differentiate with respect to x. So with respect to x, if you are differentiating, so f dash x differentiation is, differentiation of 1 is 0, right? Differentiation of x is 1, differentiation of x square is, you get it before 2x, okay? Plus so on, if there is x cube, 3x square, so on like that. Okay, here 100 x to the power of 100 minus 1, that is 99. So this is f dash of x. Here in place of x we have to substitute 1, right? So f dash of 1, f of 1 is, so 0 plus 1, 1 plus 2 into 1 is 2, 1 square into 3 is 3. Likewise you get 100 into 1 raised to the power of 99, any 1 raised to the power of any exponent, that becomes 1 only. 1 into 100 is 100. So if you are seeing clearly, this is the sum of the first natural numbers. Sum of the first natural numbers are nothing but sigma n. Sigma n is equal to, you know the formula, n plus 1 by 2. Okay, that is nothing but 100, where n is 100, 100 plus 1 by 2, and that is 100 multiplied by 101 by 2. So 2 ones, 2 50s are, so 50 into 101, you get 5050. This is nothing but f dash of 1 is 5050. Pause it and note it down. Let's see the next one. F of x is equal to x square plus 3x minus 5. Then prove that f naught of 0 plus 3 f dash of minus 1 equal to 0. So this we have to prove it. This is differentiation, right? Now for that, first we will differentiate the function. Okay, f dash of x we will write. So 2 here multiplied by 2x plus we get 3. So that is nothing but 4x plus 3 is f dash of x. And in place of x we will substitute 0 and minus 1. So that we will get f dash of 0 is equal to, in place of x, 0. 4 into 0 is 0. So this is 3. And f dash of minus 1. In place of x we have to substitute minus 1. So 4 into minus 1 plus 3. That becomes minus 4 plus 3. So that is minus 1. And we will substitute in that f dash of 0. F dash of 0 plus 3 into dash of minus 1 should be equal to 0. This we have to prove. So f dash of 0 is 3 we have plus 3 into f dash of this is minus 1. So this must be equal to 0. So 3 minus of 3 equals to 0. So hence proved. Hence proved. Pause it and note it down. Find the derivative of the following functions from first principles. Clearly here it is mentioned first principles. So we have to do the derivative using the first principle. Now the first bit and the second bit I have noted down here. Now x cube. For the first principle it is nothing but limit h tends to 0, f of x plus h minus f of x by h. Right. For that, first we will find out, let us suppose this as f of x function. This is a function of f of x. So I'll find out here f of x plus h minus f of x divided by h. First we will find this. So here function is x, so x plus h whole cube. This is f of x plus h minus f of x is nothing but the x cube divided by h. Now we will expand a plus b whole cube. So that is a cube plus 3a square b plus 3ab square. Here a and b are x and h plus b cube and also given minus x cube divided by h. Here we can cancel off these two. In the above numerator you can take h common. Okay, if you take h common, it is 3x square plus 3x h. One h is left over here and h square. So I have taken h common to cancel it off with the denominator part. Now this is completely f of x plus h minus f of x by h. But we want the first principles. Okay, so f dash, I am supposing this as f of x. Let this be f of x. So derivative of the function using the first principle. So that is limit h tends to 0 f of x plus h minus f of x divided by h. So that is, here we have to apply limit h tends to 0 for this. The simplified version of this, that is 3x square plus 3xh plus h square. So if you apply limit, here this is 0 and this becomes 0, only 3x square we get. Okay, applying h is equal to this part becomes 0, this part becomes 0. So 3x square is the final answer of this. As well we know, with by not using the first principle also we can know this is just 3x square. So we have to apply the first principle and do, that is mentioned, so we got this. Now we will see this one, x plus 4, let me write it here, x raised to the power of 4 plus 4. Okay, that's the question, I think, right? X raised to the power of 4 plus 4. Now we will, let me suppose this as f of x. So I want f dash x using the first principle. Before that I'll write f of x plus h minus f of x divided by h. Right. Here this is x plus, in place of x we will be writing x plus h. Okay, raised to the power of 4 plus this is f of x plus h. This is completely f of x plus h minus again f of x, this one, x raised to the power of 4. So minus minus again minus only we get divided by h. Here what I wrote, f of x plus h minus f of x by h. So we will expand x plus h whole to the power of 4. Okay, so x to the power of 4 plus 4x cube h plus 6x square h square. So where a and b I am replacing it with x and h plus 4x h cube, and the last one is h to the power of 4. Here remained plus 4 and minus 4 gets cancelled, so minus x to the power of 4. Again minus, and this also gets cancelled, divided by h is there. So taking common h, 4x cube 6x square h plus 4x h square plus h to the power of 3. One h I have taken it out, so to get it cancelled with the denominator. So this part is a simplified version of f of x plus h minus f of x. Now we will do the derivative using the first principle. So that is limit h tends to 0 f of x plus h minus f of x divided by h is nothing but the derivative of this one. So the limit of this one, limit h tends to 0. So that is f 4x cube plus 6x square h plus 4x h square plus h cube. Right. When we apply the limit here, when you are applying the limit here, all these terms are having h. When you are applying, h tends to 0, isn't it? So all these three terms become 0 and we get the final one, 4x cube. So here also if you are seeing 4x cube is the derivative, but we have to use the first principle and get the derivative. Okay, please pause it and note it down. Let's see the third one, ax square plus bx plus c given. We have to find the derivative of this using the first principle. So I'll suppose this as f of x function. Now we have to find f dash of x using the first principle. Right. Now here first, before finding the first principle, I will write down f of x plus h minus f of x. This we will, simplification part we will do it and keep it here. So f of x, this is f of x, so I want f of x plus h. In place of x, I will substitute x plus h. So a x plus h whole square plus b x plus h plus c. This is f of x plus h minus function of f of x. So ax square. So minus sign for all the terms. So minus bx minus c. Here that is f of x divided by h here. We will expand it. So a into a plus b whole square x square h square plus 2xh plus, opening the bracket, bx plus bh plus c minus ax square minus bx minus c h here. So ax square, if you open the bracket, ah square plus 2axh plus bx plus bh plus c minus ax square. So we can cancel over ax square, bx and minus b also here, divided by h. So if you are taking h common here, c and c also will go. H common if you take in the numerator, ah plus 2ax plus b. Okay. So divided by h. So this goes off. So this is the fx plus h minus f of x by h. So we want the derivative of the function f of x. So f dash x is equal to limit h tends to 0, this part, the simplified part, ah plus 2ax plus b. So for this, applying the limit h tends to 0, so this part becomes 0 and that's all, only this part becomes 0. So the final answer is 2ax plus b. So this is what we also know. If you directly do the derivative, here 2 comes before 2ax plus b. So 2ax plus b, but we are doing the derivative using the first principle. Please pause it and note it down. With this, we will end the class for today and we will see the remaining problems of this first principle problems in our next session. Thank you all.